Computer, perfect. All right, so first of all, welcome to join us in our monthly gathering. So this is actually the locations where we trying to have all the members come and share what they know, what they have. So it's actually the place for allowed everyone to share. Now I'm sharing my screen and I'm showing you the LinkedIn page. Are you seeing it correctly? Let's confirm.
Yeah.
My LinkedIn page. Let me move it away. Oh my God. It's a Mac. Desktop to share. Yes, great. Let me minimize it. Okay, good. All right, so you can see my page, right, on the LinkedIn. So do participate, join us on this LinkedIn page, follow it. If you see the events, then please share, don't hesitate. So you will see that we actually have a number of events that is already scheduled, right? And this is the one that we have tonight. And of course, if you follow our page, then you will find that we will have a number of different events that is already scheduled. Like this today, this is the call that we have. Then next month we will have one talk about the PLE, and then we will go into the October of our AOSEC. That's why we will not have any night discussions on October. Then we may actually organize some others on November and December, pretty much, right? So this is where we're going to have once a month a talk gathering virtually with all the members. And it is also the place where you are able to share whatever things you want to share, your experience, your knowledge, or even you have problems that want to discuss with the other members. This is the night that we prepare for all the members to join to spread out the news, let other people to know about this gathering so that we can take advantage of the membership that we have and work together, right, as a community. All right. So don't hesitate to look into that. So tonight, if you back into the events, then you will see that in tonight our topic is actually based on the meetings that I just go for Korea with the ABAC 2025 workshop. So on the ABAC, we are actually having this official workshop to talk about a lot of different things, right? So one of the topic that they have in the meeting is about the digital standards. So I'm lucky to be one of the speaker there to talk about the MBSE and the digital standard and how they collaborate together with the AI, of course. So tonight, I would like to take this opportunity to share what we are being shared in that events in that workshop. So to all the members together, okay? So this is the highlight topic that we're going to talk about. After that, we have open discussions. You can just discuss whatever you want, any topics or any question that you may have. The presentations, I will also plan to share it at our LinkedIn page. I was thinking about that, right? So we have the record, we have the LinkedIn page, or maybe we can create a channel in YouTube and then publish it. Let's see what we can do to share this material to everyone, right? So this is pretty much the presentations as it is that I did at the APEC 2025 workshop. So the topic, as mentioned earlier, is about the applications on the MBSE for the certification planning in the topic of the digital standard. So when we referring the standard, we are talking about all the standard like the ISO 26262 and the different ISO IC standard that you can buy from the PDF. So that is what we're talking about, what we're referring when we talk about the standard. So definitely the certification is a part of it, right? In that particular meeting, it's very interesting that I'm able to talk to many people from the community of ISO and IC and also C. Those people, those community is actually working on the different standard for the different industry, right? For the risk, for the automotive, for the ship, for the aircraft, everything, everyone is there. And very interestingly about what they're looking into the change in AI impacting what they are doing, right? So all this standard community, you may already know is that like the ISO IC, their products is actually the PDF file. So it is what they are selling online, right? You're able to purchase, like the ISO 15288, ISO 26226, and learn about, how to be compliant, what is the topics, what to look out for. The digital standard is actually taking the advantage on what these informations in the PDF format is, right? So they want to look into to turn this knowledge into a database and then to put the AI on top of it and then to sell it as a subscription for the company, right? So imagine that in the future, I'm building a ship. So what I want to do is to have my specifications, the design, and if I have these subscriptions, I'm able to upload my design, and then they're able to look into the design, look into the documents, for example, or the models, and then to tell me that what part of the design is actually in compliance, which part of the design is not covered by the standard, and which part of the design is actually not met into the standard what they are constrained with. So that is a part of what the digital standard is heading to, right? That is a very interesting discussion that we have with those people. So these presentations, what I did is actually representing the INCOSE, and because these are part of the working products that we did in our working groups for the MBSE for autonomy of maritime. So the topic pretty much is I give a very brief introductions about INCOSE and also the working groups because a lot of people is not really from the background of system engineering, right? You have lawyer there, you have the people that is working on the standard mainly. Then we talk about the relationship. What is the MBSE? What it means from the digital standard point of view. Then we share about the motivations. Then we show some demo that I prepared a video to show you what it look like, what can be done. And of course, we conclude with the benefit of the digital standard to use it together with the MBSE and the digital engineering. And of course, during that times that I visit, we did some hands-on, some workshop, but that is what we're going to skip here because we don't have all the equipment and everything, right? But again, we will go through what we've been done there, so you have a feel and ideas. Then, of course, we talk about the AI area that is a part of the hands-on that we're working on. Then we discuss with all the member about the advantage, disadvantage, what to look out for, and then to share about the private LLM concept architecture. And if you want to implement the AI within our organizations, what are the possible things to do? What is the solution that we are looking into in order to improve the consistency, the correctness of the response, right? And then that is how we put everything together into the demo that to show that how the AI can help in preparing the certifications planning phase. So that is pretty much what we also will cover tonight, only without the hands-on. All right. So I think this is something that you all already know, should be familiar with about the Visions 2035. If you don't know, do take some time to read these documents. I think it's pretty good documents. It gives a lot of insight, let us to think about the future. So the things that is paying attention is actually the highlighted things, the AI, how it impact what we are doing, especially from the system engineer role perspective. And you will amazed that, for example, ChatGPT 5 today, they are really improved a lot into the correctness and the consistency on the answer. And so that, it apparently that the way how we work is really impacting by the advance and the capability AI has to offer. Then the other area that really impacting our life, not just as a system engineer, is the synthetic biology. Autonomy, that will be another thing really important, and that is where we are looking into whatever we do is under the pressure of the times, and also how we're able to support these fully automate systems to system or machine to machine, machine to human interactions environments. Then, of course, everything is about the digitalizations. So the digital engineering is not a dream. It's not something that, whether we need to consider we do it or not, but rather is how we're going to do it today, right? Not whether we do it or not. So that is the change that is actually really fast because of all this technology and advancements, and they really cause a lot of impact into the industry as a whole, from in my opinions. So by having that, what I see is that the lack of ability to leveraging all these main topics will be behind, and it will be irrelevant to the industry pretty soon. So to capture all these things, right, the fundamental thing is really the system engineering, and the MBSE is definitely one of the important key technology to leveraging the system engineering and AI together into this era. So that is the topics that we are looking into. So part of that for you, some new fans here is that you will see the working groups, and there are many, many working groups. I bring up some of the very dear to my work, right? So all these working groups are very interesting and they are really very active. And the case study today is actually from the ongoing working groups for the MBSE for marine autonomy. So that is a part of the working groups, and the selected tools to use by the working group for the product we do is the Katia Magic on the MBSE. So it is a part of the SE Lab. So the SE Lab is actually something that available today as the INCOSE members. You are able to actually check out the tools, request for the trial versions, and to do the self-learning, right? Depends on the vendors. Some vendors they allow you to actually trial for 3 times, for 2 times. It depends. And for Katia, we are actually providing the tools if you actually use it for the working groups, technical products, right? So this is the part of the SE Lab that I can have to offer to all our members. After this presentation, if the member will be interested to learn about more on the MBSE, we can also organize the on-site training. I'm able to book some facility to provide the hands-on training for the members who are interested in. All right. Okay, so enough talk about the tools, right? The tools is one thing, but the very important is about, the modeling language, right? So we selected two because of its compliance to the SysML languages. So if you not know, the MBSC is mainly using the models to replace the natural language, basically, right? So use the model to actually specify capturing all the engineering data. You use the model to describe the system architecture. You use the model to describe the conopts where the system is intended to be operate. You use the models to describe your analysis case, your validation case, your use cases, all the things that to support your analysis and design. So part of this particular tools and the language that we selected and to use as the basis for our working groups. So the research topic is actually investigate the rules and guidelines on these autonomous maritime functions provided by ABS and to trying to build the ontology based on their concept and then to use the SysML to describe the actual systems in order to leveraging, the ontology and the reasoning capability together with the AI and help this ship industry advance into the MBSC and the digital engineering. So this is pretty much the goal of the groups that we are doing. That's why we have some technical prototype to actually showcase that, SysML is relevant and how we can have the model to take advantage of the AI. So, a part of the guideline, the methodology is actually based on one books. They call the Magic Grip books. So this book definitely is pairing with the tool that we use, but the contents inside is really natural, meaning that it doesn't really depends neutral and it don't depends on any tools, right? So it's really focused on the SysML language itself and what the language together with the methodology can be applied into your technical work, right? So you're able to learn how to do, and more importantly is the book is free. So you can scan this barcode and download the books, and enjoy it. Okay. All right, so looking into that, right? So why we're actually looking into this area on the digital engineering, and sorry, the digital standard, and why the certificate? Because it is highly related to the certifications, and you may also know that it's also related to a lot of safety, right? So we just pick one example, right? Look into the OEM challenge by the certifications. So like Airbus, they actually spend a lot of time, resource in order to actually prepare the products to pass the certifications, right? So the amount of times the advanced technology add into the aircraft, everything come together, it make the whole process extremely complex. So the system itself is very complex. The process to get the aircraft certified is also very complex. to evaluate the new technology that is not even a part of the certification that is being covered, even more complex than that, right? As you can see. So that is something that, the people who are building the human life related system that they have to go through, not necessarily on the aircraft, but also in the car, in the medical devices, so on and so forth. So they have all regulated and they are all depends on the standard in order to go through the certifications course. So with these motivations, we are looking into how the MBSE and digital standard can actually resolve. So look into the certification, look into the entire development life cycle. The traditional system engineering driven processes is actually depends on the documents. And the problem with documents, you all will already know, is that, update definitely is a big problem. The information also is really break down into the different narrative, different domain, and separate into the different documents, right? You have finance, you have project management, manufacturing, detailed design, the result of the analysis, the requirements, the software architecture, this and that. And they are actually only as part of the perspective of the whole systems, and everything is interrelated, right? Not to mention about, the certification into the rules, guidelines, safety, reliability, cybersecurity, interfaces. So all those complications is actually really, really difficult when you're dealing with the highly advanced systems, right? Like robotic, autonomous car, cargo ship, right? This and that. So the complex and the volume is unmanageable today. A lot of extra work, a lot of rework because the information is really by design separate into different silo, into different domain. First, so when you look into, let's say the mechanical design, then you may actually not aware whatever happens into the software design that may impact into how the mechanical work, right? So those kind of impact is very impossible to handle. And then the integrations between the departments, between the document itself, between the information is a nightmare. So that's for, everything become extremely, extremely difficult. So that's why, digital engineering, MBSE, is actually provide to be a really one of a very good solutions, especially when dealing with the digital standard as well. And the other aspect to look into is that most of the people that I'm dealing with in Asia, I don't really believe we have a system engineering aspect, right? We don't even have a role as a system engineer. So a lot of analysis and design and all those risk assessments happens at the design phase, meaning that when you're doing the 3D models, the software architecture, and also the E architecture, that is where you actually combine the analysis and the validations in once. So each of the analysis result, each of the risk assessment result is actually impacting your design that indirectly forcing you to update and change your architecture. And not to mention the change from the customers, right? So all those things become is very high costs and the rework at this detailed design is very, very time consuming. So with that said, if we really input using the system engineering with the MBSE, now we're able to shift all these analysis validations ahead of times before the actual detailed design. So the impact, the changes that happens is actually in the upfront. The change still there, but imagine that the people who are dealing with the system architecture is a way smaller teams than the one who are doing the detailed design, right? So you have maybe compared to 200 to 2,000 people, right? So the amount of time that you need to do the changes, 20%, is about 200 people change at the 20% rate, and the 2,000 people that got impact and need to change at that 20% rate. So the cost is really different. So that is what the motivation that motivate us to actually looking into the change on this one. The change is really difficult because it's really impact how we work, how we believe we should work. So a part of the changes on the MBSE, basically they can break down into a number of different perspectives and leveraging the models to put all the informations into one place and then to have all the aspect to consume the model as a starting point. So you can use the model as the basis for analysis. You can use the model as a basis for your mechanical design, analytical design, software design, also the testing and quality control as well. And the model will be correspondence to all the requirements, including the rules and guidelines from those standards. And also it will able to generate automatically on the documents or the specification that you may wish to have in the document form. So it's mean that you will have one model to put every information together, and then you are able to, from the model, extract the informations based on the different discipline as you need. So the information itself is always at a holistic stage. And when you extract the information out, you still keep an consistency into the whole data, right? Rather than what document is doing. So that is a part of the reasons why we believe that MBSE will be the solutions for these problems. So looking into that, right, the working groups after all is focused on the marine times. And then so we looking into how to use this MBSE for this digital standard. And then so we want to explore into a number of different use cases, right? So we will take into the interest into the maritime autonomy context. So the working group, we actually focus into the definition of the autonomy functions, right? So that is where we're trying to scope down what we have. So that's why we will have the ontology trying to figure out, give the definition of what is considered as a smart functions, what is considered the criteria as a good smart function or as a risky smart function, for example, right? We must have a standard ontology to define, the different data type and to support the different architecture needs, right? So to use for the sensor data, analytic models, or the control logic of the software. Then definitely the cybersecurity assessment is a part of it. For the maritime, we are focused on the UR E26 or 27s, but the solution is applicable into, for example, the ISO 62443 and even the cybersecurity on the NIST 800 series. So those are the things that can also be adopted into the framework, right? With to fit into the different industry. So those are the area that we're looking into. So as a part of the ontology, when we break down into the meaning, the definition of the autonomous functions, so we are able to use the models based on the definition on the autonomous functions to help assessing the ConOps, to perform the risk assessments on the safety, reliability, and cybersecurity. We can also use it as a basis to actually continue the design on the control logic of the control architecture, or use it to prepare alongside with the operational scenario and the failure mode. So we can reuse this information in the simulation environments to do the validations and to do the testing as well, right? So that is the ideas of what we are doing is also in alignments with the IMO mass guideline that they are proposing right now. So not just about the INCOSE and the working group, we are working on these topics, but internationally, like the IMO also heading to these topics. So it is something that is too important to be ignored. All right, so we have a number of things, right? So I will show you the video later, but what happened is just to show you how things work, right? The first step, what we're going to do is actually we are open up the PDF, right? So in the PDF is today where you find all the ISO, IC standard regulation is visited in. And you will also see that this solution is very useful to dealing with the existing system documents, right? Pretty much in today, all the document is either in Microsoft Office format or actually already in the PDF format in order to preserve the baseline to prevent modifications. So the solution is get started with by importing all the data from the PDF into the modeling environments, right? So what we can do is look into the certification. In this case study, we look into the aircraft, the part 25, about the carbons on the commercial aircraft, right? So we import all the data from that part 25 certifications on the PDF documents into the model environments and convert them into the requirement format with the SysML one. So once that is done, the next step we're going to do is to create the analysis agents. So this analysis agent, what we call the generator, is actually allow us to specify what are the things that is relevant to the current analysis, right? So at this particular demo, we are looking into to build the commercial aircraft carbines. So based on the part 25 carbine analysis, we are specify which part of the part 25 standard is relevant to the design that we are working on, right? Because on the commercial aircraft, you also have the type of the aircraft, type A, type B, type C, on the difference on the size of the aircraft, right? That's why, the first step after import the PDF, we are going to prepare the analysis agents and then to tell them that what part of the certification is relevant to the systems that we are designing. Once we're done on the regularization selections, we have the agents that is going to do the monitoring and read on the model that we design. So the second step is to build the system architecture. So the one that you see on the system architecture is using the block diagram in SysML to capture all the cabin's features, right? So we have the area for the parameters, like, how many seats on the cabin, what is the rank, what is the height, what is the distance between each of the seat. So you will see that during the pre-PDR phase, we will have the mock-up of the aircraft, and then we will have the specification capture in the models, like the one that you see. So when this is done, you will see that the feature of each of the block that represent the systems, like the passenger cabins and all the feature will be actually have the traceability trace back into the correspondence on the correspondent on the standard that they are referring to. So you will see that the measurements like the IOY, the size is actually restricted by the certification, so that traceability will be done. Now, as a part of the leveraging the AI, in the demo, what we did is we have the AI to actually learn the standard PDF, right? So the AI actually have the agents within it that understand the standard. Then we have the AI to actually also learn the syntax of the SysML. So when the AI look into the number two architecture, they were able to figure out that it is about the carbons, and they understand that how many chair is there, what is the distance between the chair, in that block structure, right? So they're able to read it. So once it read it, the AI is able to figure out between the architecture and the standard, and then to create the number three traceability automatically. So that is a part of the AI in the demo that we are able to achieve. So once we have the model done, the AI will actually automatically create the traceability for us. So as a system engineer, our job is to validate them, right? So that is where the thing is going. So once that is done, we go back into the generator, the agent that we create earlier. So the agent will read the certifications in the form of SysML requirements. Then they will read the system architecture in the block diagrams and automatically generate the certification basis for the commercial aircraft as the deliverable report. So you will see that in the certification basis, they will pretty much outline the part, the certification that is related, the feature inside the specification on the system that we are designing, and then if the feature is represent the parameters that will be a part of the inspections point, like the mean of compliance, they will also highlight it, right, automatically. So by having this AI to work alongside with system engineer, and if we are using the model base, it actually help us to automatically generate and really allow the AI agents to be the true assistants through the entire process. So it's really enhanced a lot of effort that normally had to be done, carried out by engineer manually, right? So as you can see that, the engineer to do it manually, we also have the risk of the human error as well. Plus, with the AI and the agent that we build together, they will inspect to each other. So if there is any part in the certification that is required, but our design, our specification does not cover, they are even able to highlight it in red to alert us, right? As what you can see right now. So let's look into the actions in the video. Because I'm running into my Mac. Let me see whether or not. Is it running? Oh, cool. What or not? Come on. Which? Let me see. Oh, it's too bad. Okay, I have a backup. It cannot play the media. All right, can you see the video running? Yes? You're able to see the video, right?
Yes, we can see.
Great. So you can see that this is the SysML requirements. This is what it looked like when it become the SysML requirements. So we import the PDF and then to turn it into the SysML requirements so we can treat it line by line, right? Topic by topic. And then when you go down to the mock-up of the commercial aircraft, so before during doing the planning, we must have a mock-up, right? So all the basics of the layout of the products, like in this case, the aircraft have to be outlined. So when you convert the specifications of that 3D models, so into the architecture, that is what the block diagram that you see. Of course, the same way you design on the cabin, the entire aircraft will be in this block diagram, captured in this way. So, you're actually turning the diagrams as the way to capture the detail rather than to have all these into a Microsoft Word with a table, right? So that's the main differences. So of course, a table to give you the outline that is easily consumed by humans, but the model is actually give you the relationship on top of it. So then we look into the requirement on the certification. Some of them is actually able to turn into the mean of compliance and evaluate through the simulations. So they will be converted into as the constraint as you see earlier. And then the relationship between the architecture and the certifications in here is actually generated automatically by the AI agents by reading the architecture, then reading into the specifications on the standard, and then to generate the relationship. Then you will see that some part of the equation that being converted that will be used as a part of the mean of compliance evaluated by the simulation will be also be there. And then now we are having the agents to actually specify what are the part that is relevant to this particular product independently by the compliance officer. So then we are able to run the simulations in the to do the inspection. So when run the simulations, that generator will be running as an agents, and then to read through the architecture, then read through the PDF that is imported from the ISO standard. And once the analysis is done, then they will automatically generate. So everything that being generated will be in blue color. And so that is the part of the certification that is required for the type of the system that we build. Then based on the architecture that they read, they automatically mapping and do the inspection and form the certification basis report for us automatically. Then when this is done, then you will see that it is actually capture high level of automations, right? And then if there's anything that is required by the certification because of the type of the system that we are building, it will also able to identify that the current design is not yet cover what topics, what area. So that is where we can actually leveraging the MBSE together with the digital standard as one of the use case that we are doing. Okay. All right. So when you're looking into the commercial aircraft, right, we see a very simple one. So, we don't need to have too much background to understand it. And when you go down into the real business, right, so the commercial aircraft actually break down into a number of different standards, like the ARP 4754A is all about the requirements, the system architecture, how you break down to the definitions. Then the ARP 4761 is about the safety assessments that is actually leveraging, for example, the FTA, FMEA, Markov analysis. So those kind of methods is also able to be realized and supported by the MBSE. And the ARP 4761A, the last release, is actually recognize MBSE as the preferred methods to do the risk assessments. And of course, you go down into the item level, then you have the avionic systems, the software components, then you go down into the DO17XC. And this one by traditionally is also already model driven, right? You use the models to design the avionic systems and then use it to generate the code that is compliant into the DO17XC. So you will see that the digital engineering, the digital standard, and the MBSC has a very long history working together, and we are just evolving the coverage from the very low level like the software into the higher level, into the systems, right, into the system level, into the aircraft level. So the work has been really done by the community for quite some times. So it's not some new concept here, but what we are doing right now is to really using the model base together with AI, right, to take advantage of the AI. So when you're looking into the AI, right, we're talking a lot about them. Is today, to be honest, that the potential of the AI, what it can do for us, is really still not well understood, in my opinion, right? Because a lot of people looking into the AI is about the automations, it's about the productivity, but that is the philosophy, a concept, I may say, back to the industrial revolution era. What AI can be done, right? As you can see that a lot of news about the AI is going to replace a lot of worker. But to be honest, looking into the reality is that, the AI will never replace human being, the human worker, in my opinion, but rather is looking into a next generation of the humans worker force who can leveraging using AI will be replacing the people, the engineer, who are not able to accept the change and leveraging AI. So in the other word, the new generation of worker, the human being, going to replace the old generation of the worker. That is what I believe. So that is how the AI will be impacting us. Is really the best way to look into how we can best adopt the AI. That is what my personal opinion is on this particular topic. So in that workshop, of course, we go through the ChatGPT, and now the ChatGPT 5 even way more powerful than that. So at that time, the ChatGPT 5 is not released yet, so we actually cover into how to customize the ChatGPT 5 to have it better understand yourself, better customize the result that they can provide to you. So we go through the customization that come with the ChatGPT with the audience during the workshop, but we will not do that here. And ChatGPT is actually do way better than this, right? Because now you have agents. You can even create your own agent and share with the other ChatGPT user. So that is a very, very interesting. And we will talk about that in the next section, right? So that is what we go through, how to customize the ChatGPT before 5 release, right? After this, after 2 weeks, we actually have the ChatGPT 5 release, and everything we see here become obsolete. But again, we come back into the AI tool, right? Even though AI was so amazing so far, but again, it is also have a lot of limitation, right? Based on the recently released paper from Apple. People may think that Apple don't introduce any AI, so they write a paper to try to say something bad about it. But when you go through the paper, a lot of they talking about is actually the fact, right? And then the illusions of thinking, because if we're not able to actually leveraging the agents to inspect their own result before they feedback to us, it is still not really in the production level, right? So that is the truth. In order to resolve that, we see that there are a number of different problems. So we'll talk about that later on. So up to this point, you see that we are very keen into AI. We are looking forward into the MBSE. So now, why we put all these things into the certification planning phase, right? What is the motivation behind it? So I think we are kind of go through that because of the troublesome, time-consuming, error-prone by the human process, this and that, right? And you see, just the demo, you can see that how wonderful it could be. So in order to really enhance the AI accuracy and the correctness, so this is the concept architecture that we are thinking about, right? So everything will based on agents. We want to really have many agents become the expert into the different area, and all this agent is going to work together. So the certain agent that we look into is considered as a fundamental models. So look into the agent that is really the team foundations. They have to equip with the domain knowledge. When we talk about the domain knowledge, we break down into three areas. The first area is everything related to the standard, right? So the certification rules and guideline. So this is the agent that you see earlier from the demo that is what we already built, right? We have the agent. Actually, we train the agent based on all the ISO data from the PDF. Then the second agent we are looking into is they must be the physics engineer. So they have to really understood the physics engineering. And then this agent must have the ability to reply our prompt, but not back from the natural language, but generate the code in the form of Madalika or SignLab, right? So we pick Madalika and SignLab because SignLab is an open source, where the Madalika is actually the open standard, right? So you are not really locked by the vendors of the tools. So you can have the Modelica and use the open Modelica, or you can use the Daimola from Dassault Systems or the other vendor as well, right? So we select the Modelica. So that's why we want the agent to have the ability to actually look into the prompt and then to actually, provide the feedback in the form of analysis models in the Modelica language, right? For example. Then, of course, we also need to train the system engineer language of choice, the SysML 2.0. So the SysML 2.0 is different than the one that you see because it is actually like Modelica is a programming language behind each of the diagrams. So the SysML 2.0 models language is also provide three interesting aspects, right? You're able to use it to describe the analysis case, which can be used Modelica or Pythons, right? And the other programming language too. It allow you to describe the verification case for the testing. Then it allow you to describe the use case to represent your ConOps, right? So for example, for the maritime, I can have a use case from the ConOps, then use the Modelica to actually describe the ocean conditions, right? So when I design the ship specifications, I'm able to have the 1D model before the 3D happens to simulate it in the sea conditions alongside with the other things. So that is where the agent that we have in mind, that if you want to build the intelligent agent to assist the system engineer, this will be the basis. Then, of course, the agent we will have more aspect into the actual products, right? So we need to capture what is real, right? For example, if I'm the company A, so I need to understand what product that I have capability to produce and how the product that I produce, how well they actually performs. So we need to base on the existing products. And to build the ontology based on the existing products, right? So the existing products, the data that reflect into the quality performance of the existing products, including the failure mode, the testing result, the product log, the operational log, the bill of material, and also the MRO data. So all this data is actually, you can look at them as a big data, right? It could be in the PDF format today, in Excel format today, or some good company maybe put it into structural in the database too. So all these big data, right, is where the AI, we intended to have the AI to actually read on it and then use the AI to generate the ontology models to represent the actual knowledge of the product that the company is building. So when we having these foundation models that represent the domain knowledge and the ontology model represent the actual products, then we are able to do the reasoning, able to have the agents start generating the ideas, the new concept, the new requirements, right? So we are hoping in one day that when this is done, I'm able to have a prompt to specify the system that I want by telling the agent that the prompt that what type of the system I'm building, what is the kind of conditions that I expect the system to perform, to operate in, what is the purpose of the system, right? If I'm building the ship for navy ship, for fisherman ship, for the cargo ship, passenger ship, right? Once those data description is done on the prompt, and these agents with this knowledge that I just described should be allowed able to generate the draft architecture and also a different analysis case, use case, and verification case for us to understand that the solution that they provide, what it means, right? To be honest, a lot of the requirements, the architecture that being generated, it may look make sense, but doesn't really make sense. Only through the analysis case, verification case, and use case together, we can really validate the generated informations, how accurate, how correct they are. So that's why the ability to generate the analysis case, validation case, and also the use case is the core concept of this architecture that we are working on. So then behind the patterns, we are looking into combining the planning patterns and the multi-agent patterns into one. So with these two patterns come together, we are able to actually do the reasoning and to have the agent collaborate as a team, right? So that is what we are looking into for this particular research. All right, so the workflow. So the workflow is looking into, of course, the first step is to get the data train. So we are either using the actual product database, the one that we just described earlier, or the rules and regulation from the PDF, or the other old system engineering data from the PDF, right? So once that data is in, then we have an agent to actually prepare the rack and then to perform the reasoning. So behind the rack is actually produce the simple semantic on the ontology. So the relationship, very importantly, that between each of the terms will be identified. The different terms will be classified into the different items, whether it's a functions, the input parameter for the functions, whether it's exchange items, whether it is a part of the system structure, right? The system behavior. So those kind of different classification will be done in the form of the ontology and also the relationship between them. And once that is done, that is where we start have the prompt being processed, reasoning, and then given the result and convert the result into JSON and then to import, transform into the SysML model elements, right? So this is what we are doing in the demo to support the SysML 1.x. But looking into the SysML 2.0, the JSON part can be actually removed and the answer will be straight into the SysML language or the mathematical language. That's what we are looking into. So with that done, then we are not able to show you this. I don't think it will run. Okay, so it will not run. All right. So let's see what it look like. All right. Another videos. Okay, can you see the video? So this is a set of the requirements from the standard rules and conditions that we import based on the ABS autonomous feature. So once it's import, it actually create the SysML requirement library that can be reused. So when it is done, the first step what we do is to look into the system requirement that given by the customers. So this is nothing to do with the standard. And based on the system requirements, the engineer is actually work on the system architecture. So they outline the system architecture and to prepare the feature according to what the customer needs. And of course, the certain mapping between the system requirements and the models will be actually provided and generated, right? And at the end, we are able to look into the system architecture with the customer requirements together with the ISO standard and generate the compliance checklist in the table as you see. So we already prepared three things, which is the ISO rules and conditions, and then we have the customer system requirements, And then we have the system architecture based on the custom requirements, right? Custom requirements. So now what we do is we actually invoke the LLM agents. So the agent behind, as you can see on the simulations console, we actually invoke the AI agents, right? So the AI agents, based on the certification, is actually go through all the standard, read the SysML requirements, and then look into the system requirements, look into the system architecture, and then automatically create the relationship between them, and then fill up the form automatically, and then they are able to identify the area where the certification is already covered, and the area where the architecture is there, the system requirement is there, but the certification is not yet covered, right? So this is where how the AI is able to look into the model that we do, and then help us to accomplish the traceability and to ensure the end-to-end relationship traceability is actually maintained, right? So the accuracy is really about the timing to train the data. So the data scientist, data engineer is absolutely required to improve the AI feedback. So those are the concept what we are actually working on, right? So then you can see that by doing that, then everything is really high level to be automate. And then the very important part is that it's not really trying to generate something smart, but to look into what is already there, what we already built from the engineer, and then to make sense out of it and to prepare the traceability. So you can see the things that need to be satisfied for the system requirement is there. When the system requirement is actually related to the standard, it will give the derived relationship to make sure that we know that the system requirement given by the customers is also restricted by the standard, not just on the system architecture from the block diagram that you're seeing here. So this is a part of the solutions that we are looking into from our working groups that is relevant by combining the MBSE and also the digital standard. Okay, well, come back. Okay, right. So what we see so far, we have the rules and guideline from the ISO convert into the SysML requirements. Then we have the customer requirements as the system requirements. We have the system models that represent the system specifications. That is done by the system engineer, by the way, right? The number two. Then number three is invoke the AI agents. So the AI agent is actually read the rules and guideline, read the system requirements, and read the system architecture, and making sense out of these three informations, and then trying to relate them with the different relationships such as satisfying, verifying, and derived. When the relation is done, then they combine everything into the compliance checklist for us automatically as a step 4. So this is how we envision the AI assistants can actually help the system engineer to do their job better and faster, right? So you will notice one very interesting thing is that compared to the previous demo is actually done using the traditional simulations, right? Without any smart AI involved. So the relationship in the previous demo is actually done by the engineer, right? So it's prone to be the human error. But this demo is actually replacing the traceability where the system engineer is doing it by having AI to actually identifying those informations and to establish the traceability. As you see that the traceability is a very important things and activity that the system engineering will have to perform. But unfortunately, because of the troublesome that, time consuming, a lot of people just really ignore it, right? So we are not able to do that. And that is how this whole things work. And we see that those kind of necessary evil that the system engineering work that we need to perform, that is exactly what we believe the AI engine can do the great job and then to help us to cover them. All right, so this is pretty much the takeaway. So we integrated the regulations, the standard for the compliance checking is one of the use case that we see. Then we also look into the opportunity for AI to decode the natural language and turn some of them into the measurable unit and promote them into the mean of compliance whenever possible, right? So turn the sentence into equations and then to label them as the MOC. That actually improve the efficiency and the accuracy. And then it is really very scalable and adaptable. The only thing is that, the cost to train the AI is really quite challenging, right? Because, we do everything using the Olama, using the very local, laptop on the Lenovo. So, the resource on the computing power is really limited. But with the limited resource, we can accomplish quite a good proof of concept demo. It's quite impressive to look into what the AI can do. So the whole discussion is based on a number of different reference that you can see. And so this is the reference that talk about the digital standard and how to use it in the MBSE context, right? And this is pretty much the end of our discussion tonight. And this is what I share at the APEC 2025 workshop back in July. Okay, so now it's a discussion time. Any feedback? Anything you find it interesting? You like? Don't like? Believe? Don't believe?
Robert, just one question. For the standards, is it formatted to fit the software, or generally any standard with PDF can be decomposed automatically by the software?
Actually, the standard is general, right? Because it can be aircraft standard ISO 26262. So it just it's the data that we feed to the AI to train the agents, right? So we really have no knowledge how the training result will be. That's why I say the data scientist and the data engineer have to be involved to actually help to fine tune the agents, right? Of course, traditionally, this guy, the data scientist and data engineer could be labeling, the result and then retrain them again, again, and again. There are a number of research also looking into how the AI itself can actually, train it better, right? Like Elon Musk to actually having the AI as a physicist, then whatever answer that do not pass the physics AI, it will reject, right? Because you don't supposed to say something that is define the physics, right? So yeah, anything. So it's not really what you see is too independent, by the way, right? The only thing that we rely on is the SysML language, and SysML itself is a standard, right? It's also an ISO, by the way. So we trying to leveraging the standard, like go to the mean of compliance, the equations. If it is dealing with multiphysics, then we can leveraging the Modelica. Because you look into the LLM, the AI today, the capability is not just chatting with humans, right? It can actually write code, generate code. So the capability and the potential this assistant can do for us, and if we leveraging the MBSE, what can be automated is pretty much limitless. Did I get your answer?
Yeah, sure. But I thought that the standards were actually provided, and then there's a fixed function on the software to decompose it. But
Oh,
seems
no,
that that one is also AI generated,
yes, correct. It is
AI
not.
decompose, right? Yeah. Okay.
Yes, correct. That's why I mentioned earlier that there is a classification tree. The AI is actually responsible to form it, and then they form it in the ontology models to represent the classifications. Yeah. Actually, the ontology also is handy for us as a human being to inspect, right, what the AI is doing. Any other interesting topic? Any other thought? Any other questions? All good? Thing you like? Thing you don't like? Is everything clear? All right. So I will try to publish this video too. Let me think about it. I will discuss with Xiaowei, our chair on programs, and then we think about maybe we have a YouTube channel, what to do with the video recordings. The slide, I will also publish it as a PDF, right? I'm just thinking whether I should publish it in the page because it may be exposed to everyone, or should I just publish it in our community groups, right? So for you who do not know, we have INCOSE Singapore chapter community inside LinkedIn. It is a private groups, meaning that only the members can access it. So I think it could be the way that how we decided to release the recording and the slide. So it is not final yet, but anyway, I'm intended to share what we have here. Okay, so when you're looking into here, let's see. Then if you go to the LinkedIn, we have a Singapore chapter groups. Okay, so if you are not within the groups, you can join. We are not restricted only Singapore member to join, basically. So if you join the groups and then you're able to access the slide. So I will publish the slide in the groups and the video for the groups. Okay? Right? You can try to find the Singapore, INCOSE Singapore chapter groups. And then all right. So the next events will be all August 22nd, this Friday. So we will have a gathering tonight, Friday night at 7 p.m. Pasir Ris Mall, Pasir Ris Central, right? So if you're around, if you are free, you want to have a physical meetup, come and join us. So depends on who is coming on this night, and then we may decide where to go after we see the people, right? We may go to a bar to have some beer, or we go to somewhere, and it's casual, okay? We don't have anything to think about, just to have a casual meetings, right? If you are free. Not free, that's also fine. All right. So no worry. So this is the next gathering that we have. Then we also will have another events coming this September 3rd at 7 p.m. as well. So our speaker is Marco, Tim, and also Hugo. And Tim is actually the SysML AI guy too, right? So they're going to talk about the feature-based part to the product line success with the MBPLE. And also they have a book just released this year on this particular topics. If you're interested about the product line and want to see how the MBSE can really help you to leveraging the product line to save money, then definitely come and join this talk together. Okay. So if you don't have anything interesting or questions or any topic want to discuss, we will pretty much end tonight discussions and to get back your personal time. Okay. But keep in mind that this is the platform that we opens for all the community to join and share, right? If no topic, then of course I will always come and say something, talk something, right? But I really hope to see our community to start sharing and to present something, not just me talking alone, right? Okay. All right.
Yeah,
Any? Yeah,
thanks,
go ahead.
Robert.
All good? Everyone good?
Yeah, thank you.
All right. See you.
Okay, thank you.
Thank you. Bye bye.
Bye.
Oh.